next presenter is Samuel Umeh.
Good morning, good afternoon, from anywhere you're joining the world. I'm Samuel Chibuzo Umeh. I'm a PhD candidate at the University of the Basque Country. I'll be presenting a paper on forecasting agricultural outputs using machine learning approach based on random forest algorithm. How important are climate, environmental and climate variable. This paper is between by me, and then um, it's a collaboration with Kainde Blessing Faloni and Oleshuna Olowale Awe. This is the abstract, and then the outline of the work will be motivation, the objectives, the literature, the data methodology, the findings and the discussion, conclusion and policy recommendation. The motivation of the work. We know that the world we are faced with the food insecurity crisis, especially in sub-Saharan Africa, Nigeria, which the work is, which the study is on. And there are three issues that's leading to food insecurity at the moment: the COVID-19 pandemic, the climate change, which has always been, and then the Ukraine invasion by the Russian Federation. Agricultural output in Nigeria has been volatile, according to Falola and Hilton in 2008. And we know there are studies that and is evident that climate change affects agriculture in all sectors: crop production, livestock production, fishery, and forestry. And the prediction of agricultural output is growing into a significant challenge faced by agricultural organizations and institutions. And traditional econometric models or statistic models are unable to forecast agricultural output with high accuracy. And so this is the need for the study using machine learning models based on random forest algorithm. The objective: to determine the best machine learning model for predicting agricultural output using climate and environmental variables, and then evaluating the impact of climate and variables on agricultural output and food security. That's after the model selection. And here's the conceptual framework. That's the definition of climate change according to IPCC. It refers to the changes in the climate mean variability properties that continue over a prolonged period, typically within decades or more. And then food insecurity exists when all people at all times have the physical and economic access to sufficient, safe, and nutritious food that meets their dietary needs and food preferences for an active and healthy life. And so, in the case when this is not evident, then we are experiencing food insecurity. And there are four dimensions of food security. That's food availability, access to food, food utilization, and food stability. And this work is looking at food availability. That's agricultural output, that's supply of food. And machine learning involves building mathematical models to help understand data. Is a sub of artificial intelligence that's allow a computer to learn from data, train the data, and then use it to make predictions. There are theories that support this work. We have the anthropogenic climate change theory or anthropogenic global warming theory. And we have the Ricardian cross-sectional theory and also the production function theory. But most importantly is the agricultural global warming, which is the most popular climate change theory. So it tells us of the impact of climate of greenhouse gases emissions on humans and primary on humans, and then talking about farming, species extinction, crop failure, extreme weather, famines, and hundreds of other calamities that are caused by artificial CO2, that's man-made CO2. And then the Ricardian is looking at the Ricardian cross-sectional theory looks at how variations in local climate affect land value, the net income on the land value of land. Why the production function theory looks at how crops are examined in various climates. The empirical literature There have been studies on climate change and the impact on agricultural productivity, and they established relationship between climate change and agricultural output. And we find Jacques found that climate change on a global scale will lead to decrease in agricultural productivity and a surge in prices of food. And we can see that in Nigeria now with the flooding, the agricultural productivity will reduce and the prices of food we are already skyrocketing. And then there have been studies on using data mining, machine learning models to predict agricultural yield. The data was gotten from CBN and Climate Change Knowledge Portal, and then also from World Development Indicators, and also from countryeconomic.com. And the variables include temperature, rainfall, CO2 emissions per capita, and then agricultural output. This is a picture showing the trends of each variable. We can see that for agricultural output, rainfall and temperature, they have an increasing trend, but more fluctuations between temperature and rainfall. And then for CO2 emissions, we see that there's a decreasing trend. That means CO2 emissions per capita is reducing in Nigeria. The methodology we used is the machine learning, as I've said, but most especially random forest after the model selection. And random forest is an assembly learning method in which several decision trees are trained, each with a bootstrap. So it's average multiple deep decision trees, and then this is trained in different parts of the same training set. And the goal is to overcome the overfitting or found in individual decision trees. So the findings, sorry, the table is not here. Sorry. Please, can you share my own slide, the one I sent to you? The table is not showing here. It's not also showing there. Okay, the model performance, it shows the different the different models that were the 6 machine learning models that were used, and then random forest performed more better, as you can see from the abstract, that it has the lowest random mean square errors. And so because of that, we had to use the random forest. So by the feature importance plot of the random forest, we saw that temperature had, look at it at 100. That shows that it's the most important predictor of agricultural output. And then CO2 emissions, but why rainfall does not is not important in predicting is not important in predicting agricultural output in Nigeria. And then the correlation plot, we see the relationship between agricultural output and rainfall, temperature, and CO2. The agricultural output relationship with rainfall is positive, but it's at around 0.4, around that 0.4. So it is like a weak positive, and then temperature is like a strong positive, while the relationship between agricultural output and CO2 is also a strong negative. And the relationship between temperature and agricultural outputs being positive can be explained that in northern part of Nigeria contributes larger percentage to the agricultural output, and most crops cultivated in northern part of Nigeria need high temperature. And so as temperature increases, it favors most of the crops that are grown in high temp in high in the north. Why rainfall relationship with agricultural output could be explained by the less contribution of temperature susceptible crops to the total agricultural output. Then CO2 emissions relationship with agricultural output is negative. There are two ways to explain that relationship. One is through the channel of economic growth. According to the EKC, that's the Environmental Kuznets curve, it states that the more CO2 emissions, the more there's economic growth, there's more CO2 emissions. So therefore, if there's more CO2 emissions, and which tells us that it's more economic growth, that tells us that there's more manufacturing. And when there's more manufacturing, there's a shift from agriculture to manufacturing. Then also, when there's more CO2 emission, it leads to rising sea level and floodings affecting crops negatively. It also leads to ocean acidification, which also affects fishery, and also it affects crop and water for the cattle, for the livestock. So we see that it has negative effect on agriculture in a way. So the conclusion is that climate affects has a relationship with agriculture, and it affects agriculture. And the best model for was the random forest, which had the lowest root mean square error, and the MAE. And the very important variable importance result shows that temperature is the best predictor of agricultural output in Nigeria, followed by CO2 emission, while rainfall does not predict the agricultural output. When we also discovered from the correlation metrics that there's a strong positive relationship between temperature and agricultural output, a weak positive relationship between rainfall and agricultural output, and a strong negative relationship between CO2 emissions and agricultural output. And here are the policy recommendation. One, they need to be the farmers and the government and policymakers need to adopt climate smart agricultural practices. And then there need to be climate and environmental education, especially for farmers. Like one of the speakers talked about education needed, and this education through tech for to achieve the sustainable development goals. So there need to be climate and environmental education for the populace and for the farmers. And then there need to be policies on how to pursue carbon neutrality or reduction, also with research and development, so as to invent more technologies that will help the farmers, so as to ensure food sustainability and security in Nigeria and other developing countries. Thank you very much.
Thank you very much, Samuel, for the wonderful presentation. There are no questions at this time due to our limited time. Thank you, and we hope to see you again and participate in the World Sustainability Conference. Thank you very
Thank,
much for being here.
thank you.